Seventh grade, this is a little bit better lesson to do interactively, maybe even more so than most. I think most things are better interactive than a video. But today we're talking about kinds of angles, and if you were here, I think if we went fishing around your memory banks for kinds of angles, you'd probably be able to come up with some. So I guess to make this semi-light class where we'd be interactive, I would ask you to pause the video, see if you can think back through your memory banks of any kinds of angles that you can think of. A blank angle, and see if you can fish out 1, 2, 3, or 4 of those answers for a second, and then resume, and I'll keep talking. So the most common kind of angle people most often remember is a thing called a right angle. If that sparked any other memories, maybe pause the video, see if you can think up any other ones now that we tapped into a memory. The second most likely to remember would be a toss-up. Maybe acute would be in there, or maybe obtuse would be in there. Sometimes people remember those. And then there's another thing called a straight angle. That is the least likely one for people to come up with. Next time I see you in person, we'll do a quiz, a small vocab quiz. I'll ask you to do a name and then also do a definition of angles. So doing the names, right, acute, obtuse, and straight, that's 4 of the 8 points. Maybe practice your spellings a little bit. There's no double letter there in acute. You know, the straight sometimes gets people because there is a straight that doesn't have the GH in it. That's a geography term, but that's not a math term. But straight, obtuse, acute, right, that's our titles. In terms of definitions, we're going to do the definitions in terms of degrees. We measure angles with degrees. So if that's a thing that you remember, pause the video, see if you can remember how many degrees any of these have, and that will be our next selections here. Right is an angle that is 90 degrees. You don't have to draw anything for the quiz, but if I wanted to draw you a right angle, I would draw something like that that makes a perfect L. I'd put a little square in the corner to show that it's a right angle. A word perpendicular, we learned earlier in this year when we've done that little square in the corner before. That's a way to show that that's a perfect 90-degree angle. Acute is narrower. An acute angle would be narrower of a mouth, if you imagine that as like an animal's mouth. It would be a narrower thing than a right. Acute has to be over 0 degrees, but we need to stay under 90 degrees. And that makes an acute angle. Obtuse opens wider than a right angle. So if I go something like this to be wider than a right angle, that's obtuse. Here we'd want to say that it's over 90 and it's under 180. Straight is if we picked a point and we went one side straight to the right and the other one straight to the left, and it would look like a straight line, that's a straight angle. That is exactly 180 degrees. So the quiz we'll do next time, I'll say name and define. So you'd say right, 90. Acute, over 0, under 90. Don't say that it goes from 1 to 89. That's wrong. It's close to right, but like 89.5 is still an acute angle. Angles can do decimals or fractions. You know, if we had a 0.2, that's not between 1 and 89, but it is over 0 and under 90. So whole numbers are not the only way to measure angles. We could do decimals or fractions. Obtuse is a word, over 90, under 180. And then straight is exactly 180. So know those, that'll be 8 points. That's part of what the homework will ask you some questions about, those types of angles. You don't have to draw them. Name, definition, 8 points. Then we have another word today, the word similar. I don't remember, let me pull one of these quizzes out, right back. I don't remember if the word similar makes that quiz. It does not, but there's a bigger quiz coming up that this definition appears, but that's a couple days away. So if you want to start to get this definition into your brain, that's a good thing for the long term. But the next quiz is only 8. This definition will appear a little bit later. When shapes are similar, it means they have the same shape, but they're not necessarily the same size. Not necessarily the same size means they could be the same size, but it's not necessary. It doesn't have to be. Okay. I'll think of a phrase I could use that for. So like, I don't know. I think I explained that. It means they could be the same size. They don't have to be. The size isn't necessary to be the same. So if you want to pin the board here for a second, I have pairs of shapes, little square, big square, little triangle, big triangle. These circles, if I could draw, I'm trying to make them be the same size. I don't know that I nailed that, but that's pretty close. Some rectangles, triangles, different things. We have 9 pairs of shapes. Some of these pairs of shapes are similar to each other because they are the same shape. And it doesn't matter if they're the same size or not. We don't care about the size. We're just looking at if the shapes are the same. If one is like a miniature version of the other one. Some of these pairs of shapes are similar, some are not. What you might want to do, just to make this a little more interactive, is pause the video, decide from that pan of shapes whether you spotted any that were similar, or maybe you spot some that aren't similar, and then I'll go through them and
the whole board's on.
Whole board's on
Yeah.
view now? Okay, so we could just sort of scan those out and just decide. Some of these shapes are pretty little, but that's okay. So number 1, I'd say yes, these are similar. This is a bigger square, this is a little square, they're both squares, which makes them the same shape. Any square would be similar to any other square in the world. If these were the same size, we'd still say yes. So if I drew you 2 identical squares, we'd say yes. Any 2 squares, we'd say yes. Anything that's the same shape, we say yes. We're not taking size into consideration, whether it's same or different, we don't care. 2 is also a yes. Okay, I spun it and I shrunk it. So I took this triangle, I miniaturized it, I spun it, okay, but those are similar triangles. These 2 sides are the same as each other. These 2 sides are the same as each other. I have a diagonal that's a little longer. This diagonal is a little longer compared to its friends. This had a right angle, that had a right angle. It's the same shape. One is a mini version of the other one. So yes, those are similar. 3, yes, these are similar. They're both circles. Any circle would be similar to any other circle. Okay? That's true about squares. That's true about circles. It is not true about triangles. Not every triangle is the same shape as every other triangle. We have some differently shaped triangles that exist in the world. But circles, always. All circles are similar to all circles. All squares are similar to all squares. The fact these were the same size doesn't matter. If I drew you a big circle, little circle, you'd still say yes. All circles are similar to all other circles. Rectangles are like triangles. Maybe they're the same shape, maybe they aren't. What they have to do is like preserve their proportion. One has to be a mini version of the other. By preserve their proportion, I mean if one of the sides shrinks, the other side needs to shrink too. The sides need to like shrink and grow together. If I like triple the one, you'd have to triple the other. That's just, they have to grow together. I would say yes on this. I'd say if I shrank this down and the height and the width both shrank at the same rate, this miniaturized would be this. If you're watching your sci-fi cartoon and the villain shot this with a miniaturizing ray, it would shrink and it would be that shape still. These are the same shape, even though the sizes might be different. This is a no. These are not the same. Okay, this one, it shrank this way, but that's not the same shape anymore because it didn't shrink this way. If I wanted to shrink it this way, it could probably only be about like that tall. If I did this little shape about this tall, then I'd say, yeah, those are maybe similar now. But we shrank one way and we didn't shrink the other way. So no, those are completely different shapes. They're both rectangles, but the shapes of those rectangles are very, very, very different. This looks like a pencil and this looks like a building. Those are not the same shape. Likewise, this is a no. Those are not the same shape. Okay? This triangle is really, really pretty tall. These sides are really, really long compared to the shorter friend, whereas these are all the same size. Those are 2 different types of triangles. Okay? They're different shapes. That's not similar. This is a no. I've got a square compared to a rectangle. Those are different shapes. We need them to be the same shape. So 7 is a no, not happening. 8 is a yes. I think those triangles are the same shape. I'd say these two are both probably similar to this one. All 3 of these really are in the same shape family. This got shrunken and also like tipped over. Okay, we can move them in space and turn things, but they need to be the same shape. So those are the same shape. I'd say yes on this, and I'd say no on this. Those are not the same shape. They're both rectangles, but like I flopped this one over, but it got maybe longer. Like this compared to this is maybe even longer than it was before, and it got like super skinnied out. Those are not the same shape. If I wanted a similar partner, it could probably only be about like that long. That little tiny thing is maybe similar to that, but no, what super long skinny is not a similar rectangle to that. So bottom line, rectangles, maybe, maybe not. Make sure they preserve their proportion. Triangles, maybe, maybe not. Make sure they preserve their proportion. Circles, always yes. Squares, always yes. Other shapes, yeah, they'd be maybe, maybe nots too, depending on if they kept their proportion, but I think our book only tests out those shapes, if I'm remembering right. Homework that builds off of this, we are working 261. We're just doing everything on 261, just the one page. This did cover 2 lessons, 107 and 108, but 261 is the page. Don't forget, study for the vocab. Make sure you know those 8 points, and I'll see you next week.